Hello everyone, I am Subhadeep and I am a postdoc at Boston University. The title for today's talk is Query Language Support for Timely Data Deletion. In this talk, we will discuss about the importance of timely and persistent deletion of user data, and toward this, how we can translate the legal requirements for data deletion into system interpretable instructions by extending the query language support. So over the past 2 decades, we have experienced an exponential growth in the rate at which data is being generated. And this can be attributed to a number of data-centric technologies such as the Internet of Things, smart cities, edge computing, and so on. Thus, as database researchers and practitioners, we have faced an urgent need to support simultaneously fast ingestion of data and fast query processing. And this has led to the birth of out-of-place paradigm. And today, we see a large number of relational array-based and NoSQL systems that are based on this paradigm. This is because the out-of-place systems can support fast ingestion of data without interfering with query processing. And they do so by realizing updates and deletes through ingestion of new entries that logically invalidate the older entries. The logically invalidated entries are later merged with the live entries lazily, which keeps the space amplification on check. And lastly, to ensure query correctness, such systems maintain an order for the ingested entries. So now, if we look at deletes in an out-of-place system, we see that given a delete statement, the system does not go in place and delete the target entry. Rather, some systems maintain some sort of a metadata that separates the live entries from the logically invalidated ones. And then the system realizes the deletion by ingesting a new entry that renders all older entries with a matching key as invalid. Maintaining the ingestion order of the entries, therefore, helps in ensuring query correctness. However, if we take a closer look, we observe that the logical deletion does not persistently remove the target data object. In fact, the logically invalidated entries are retained in the database perpetually without any guarantees on when they would be physically purged. This has severe implications on the privacy front, especially in light of the newly enforced privacy regulations. Among other things, these regulations bring to the table an important policy that concerns data deletion. It allows the end users to express their preferences about deletion of their personal data. Toward this, recent endeavors at the system level have been opportunistic enough in addressing specific delete use cases to facilitate timely, persistent data deletion. However, if we look at our larger objective of building data systems that can ensure privacy through deletion, we see a prevailing gap between the policy layer and the system layer. We point out that there is a lack of support from the query language at the application level in terms of expressing the user deletion preferences to the underlying system. Toward this, in this work, we first extract the different types of deletion requirements from the policy layer, and then we augment the query language at the application layer to support those requirements. Going over the privacy regulations, we identified two classes of requests that need to be supported. First, we have the retention-based deletes, where the user sets a retention duration and any data older than that must be persistently deleted from the database by the service providers. This class of deletes is rolling in nature, and the retention duration is typically specified as a part of the SLA. The second class of deletes supports on-demand data deletion subject to ad hoc user requests. Users may submit their deletion requests through an API, and the service providers must persistently delete the user data within a threshold duration specified by the deletion regulations. Next, we will see how we extend the query language, in this case SQL, to express the deletion requirements. To support the retention-driven deletes, we extend the create table DDL and the insert DML in SQL. The create table statement allows an application developer to specify the different retention durations supported as a table property. So in this example, we have created a table that supports retention-based deletes with specific retention durations of 6 months and 1 year. Now, when ingesting data into the database, an entry can take a value from the list of values supported under the with clause. Note that the with clause here is optional, the absence of which would indicate that the table does not support any retention-based deletes. Similarly, an entry without a retention duration specified would be retained perpetually. The fixed clause indicates that the retention duration supported are known a priori, which is largely the case in practice as they are specified as part of the SL. However, if this is not the case, we can simply use the keyword arbitrary, which would indicate that entries ingested in the database may be associated with any arbitrary retention duration. This is particularly useful when working on distributed frameworks that replicate data across physical data stores located in different geographic locations. Next, we will see the SQL extensions proposed to support on-demand data deletion in a timely manner. For this, we first introduce the notion of delete persistence threshold, or DPT. This denotes the duration within which all copies of a user data under deletion must be physically removed. To support this, we further extend the create table DDL, where every table is associated with a set of DPTs. In this example, we see that table R can support 3 different DPTs of 30, 45, and 60 days. Then we augment the delete DML, where every deletion request is assigned a DPT. This assignment is done automatically at the system level based on the regulatory requirements. So together, the proposed SQL extensions allow us to express the deletion requirements to the underlying system. So now, with the policy layer at one end and the system solutions for data deletion at the other, we have outlined the holistic framework for designing systems that can support privacy through deletion. Having said this, there are still a few missing links at the system layers. Looking closely, we can see that existing data systems may need to update their APIs in order to be able to capture the newly introduced deletion requirements. Further, implementing persistent deletion policies at the file system level remains an open challenge. Finally, even if we can guarantee persistent data deletion, the physically deleted data can be retrieved from some devices, necessitating a deeper look at secure deletion from the device level. So to conclude, we can confidently say that the data systems community is now aware of the importance and the challenges about persistent data deletion. Yet, we have several steps ahead of us before we can reach our goal of building deletion-compliant data systems with the ability of demonstrating regulation compliance when needed. With that, I would like to thank you all. If you have more questions, just visit us at our website or reach out to us.